Good day, everyone. Today, I will be discussing the graph-theoretic deterministic algorithm. The graph-theoretic deterministic algorithm is a widely studied class of algorithms for systems consisting of processes with known CPU and memory requirements and a known matrix giving the average amount of the traffic between each pair of processes. Or shall we say the recall assumptions of deterministic algorithms, in which here the communication requirements are known. There can be more processes than processors, in which case multiple processes are allocated to one processor. If the number of CPUs is smaller than the number of processes, several processes will have to be assigned to each CPU. The idea is to minimize network traffic. The system can be represented as a weighted graph, with each node being a process and each arc representing the flow of messages between two processes. The problem then reduces to finding a way to partition, example, cut, the graph into k-disjoint subgraphs subject to certain constraints, example, the total CPU and memory requirements below some limits for each subgraph. For each solution that meets the constraints, arcs that are entirely within a single subgraph represents intra-machine communication and can be ignored. Arcs that go from one subgraph to another represents network traffic. The goal is then to find the partitioning that minimizes the network traffic while meeting all the constraints. I have examples here shows two ways of partitioning the same graph yielding two different network loads. In example 1, we have the partition graph with processes. In partition graph with processes A, E, and G on one processor, processes B, F, and H on a second processor, and on processor 3, or in the third one, the processes C, D, processes C, D, and I on the third. The total network traffic is the sum of the arcs intersected by the dotted cut lines, or 30 units. And in example 2, we have the different partitioning that has only 28 units of network traffic, assuming that it meets all the memory and CPU constraints. This is better choice because it requires less communication. Thank you.